Welcome everyone to today's movie. In today's movie we're going to look at some time series data and we're going to fit a trend line to that data using least squares regression, and in this movie we'll use Excel. In another movie later we'll use SPSS to solve the same problem. So if we go to the Excel solution first, you'll see that what we have here is example 10.4 data from the textbook. And in this example, we will use a time series representing average annual UK petrol prices in pence per litre from 1983 to 2020. The time series, as you can see on the screen, so we got year 1983, period 1, and we got the average annual UK petrol prices of 36.7 pence per litre, and in 2020, which is time point 38, it was 119.9 pence per litre. What we wish to do is to create a plot of series against time point, and then once we've done that, we want to fit a trend line to the data, and then once we've done that, we want to then extrapolate that trend line into the future. So for 2021, time point 39, so we want to extrapolate to get what the trend line would predict for 2021, 2022, 2023, etc. So time point 39 to time point 48. Okay, so now there's different ways of doing this, of course. You could use the Excel trend function to calculate trend. What I've done here is I've used the original method, which is to calculate the intercept and the slope of the line. So the intercept can be calculated using the intercept function in Excel for the cell references C4 to C41. So you look here, you can see it goes up to C41. And for the X references, which is B4 to B41 as well, as you can see there. Okay, if you put the values in, you'll get the intercept B0 is 20.96 to do with 2 decimal places. And the slope can be calculated using the Excel slope function. And if you put that in, you'll get 2.879. Notice, look, there's the Y value, C4 to C41. That's the known data. And the X values is B4 to B41. That's the known data. We can calculate and measure reliability by calculating the coefficient of determination using the Excel RSQ function. And you can see that comes out to be 0.89 to 2 decimal places. So it's 89%. So 89% of the data values are predicted by the line values themselves. So we've got a small error, 11% error. So okay, what we're going to do now is let's plot the scatter plot. So all we need to do is to highlight the trend values. Okay, we'll do the series first, shall we? So let's do the series first. So if I highlight the series values and then click on insert, and we want a line graph, so we click on the line graph. Let's do the first option. So there's my series. That's how my series varies with time. Now obviously we could put the title in there, we could put the vertical axis, which is the series value there, we could put the time point title in there as well for the horizontal x-axis, but we'll leave that for you to do. Okay, now what I want to do now is I want to fit a trend line to that data. So all I need to do is click on it, right click, add trend line, and there's your trend line. Okay, now you can then modify the way it looks. Now what we want is to display the equation on the chart and also display R squared on the chart as well. Okay, and if I just close that just for the time being, you can see that those values there are exactly the same as what we got using the Excel functions slope and intercept and RSQ. Can you see there? Look, R squared coefficient of determination is 0.8927, 0.8927 to 4 decimal places. There's the slope of X, 2.88, look, 2.88 to 2 decimal places, and the intercept is 20.964, well, it's 20.964 to 3 decimal places. So you get exactly the same equations. Okay, now if you wanted to get the forecast, all you have to do then is just to extend those values down. There we are. So the predicted value for the trend line for the first forecast value of 2021. Remember that data series doesn't exist. It's time point 39 and it's 133.28 pence per litre. And then for time point 48 it will be 159.20 pence per litre. Okay, so I just yellow that. So they're your predictions based upon the trend line fit. Now if you wanted to put that onto the graph, all you need to do is highlight that data to there, copy, and then click on the graph, right click, paste, and as you can see it automatically will then fit the trend line in. All we have to do now is press escape. There we are. So there's your trend line, and again you can put your title in for your trend line, your series in, etc. So if I just move this out of the way, if I make that bit bigger for you so you can see more clearly. There we are. There we are. So that's how you take some time series data, in this case series, you fit a trend line, you create a scatter plot, and you can plot the actual trend line on the scatter plot and then use it to extrapolate into the future to give you predictive forecast values for the time points where you don't have your series data, like time point 39 that corresponds to 2021, etc. So in the next movie we'll look at how do we use SPSS to solve the same problem. Okay, bye for now. Oh, before I finish, you can also fit a prediction interval for this time series using this method, using the trend line method, and we'll look at that in another movie. So bye for now.